Hello student, okay, kita akan mulakan chapter 4 iaitu capacitors and inductors. Okay, capacitor inductors ni ada dua juga. Okay, ada series dan parallel. Okay, but this one is different between the resistance. Okay, kita akan buat in this one series and parallel capacitor and series and parallel inductor. Okay, what is the important of the inductors and capacitance? Capacitor inductor ni adalah storage element. Okay, when kita connected to the source, okay, dia akan charging, dan after discharging, capacitance tu akan act as a source pula pada our circuit. Okay, so the first important thing you know what is the passive element of the capacitor. Okay, for this learning outcome you must know how to calculate series and parallel of the capacitance and inductance. Then number 2, you know how to solve circuit problem for series and parallel connection of capacitor and inductor. Okay, capacitor. Okay, consists of two conducting plates separated by an insulator or dielectric. Okay, so it is a passive element able to storage energy in its electric field. When it's a large capacitor value, that means more charge can be stored. Okay, so the unit is we measure in farads. That means the ratio of the charge on one plate of a capacitor to the voltage difference between the two plates. Okay. Okay, when the supply is removed from the capacitor retains the storage, the stored charge. Okay, tapi bila mana capacitor is long term connected to DC, it will act as an open circuit to DC. Okay, the voltage on the capacitor cannot be changed abruptly. Maksudnya it cannot be changed suddenly. Tak boleh tiba-tiba akan berubah. It will discharging. Okay, so the amount of charge that a capacitor can store per volts across the plate is capacitance equals to 1 farad. That means 1 coulomb per volt. Okay, capacitor have two category, polarized and unpolarized. Polarized, you have the polarity plus minus, same as voltage, plus minus. Okay, but unpolarized, no. Okay, the connection can be the one you tak perlu tahu dia punya polarity lah. Okay, dia tak ada polarity, so we use the calculation by using this unpolarized. Okay, the equation you must know is number 1, current voltage relationship is more important. Okay, this is more important. Okay, and the second one is this one, energy stored in capacitor. That means work done. How many work done in joule? Okay, the unit is in joule. Half C is the value of capacitance, V is voltage. Okay, series capacitor. Okay, capacitor, the calculation is a different different from your usual resistance. Okay, for series capacitor, you must calculate as a parallel of resistance. Okay, for example, now you have here you have C1, C2, C3, C until Cn of series connection of capacitor. Okay, now you must calculate the capacitance in series, the total capacitance. So you must calculate as you want to calculate the parallel of resistance. For example, here 1 over C equivalent, okay, over 1 over C1, 1 over C2, 1 over C3, and etc. Okay, so C equivalent, you must 1 over C equivalent back. Okay, same as the parallel concept or resistance for series capacitor. Okay, for example, here I give, okay, for parallel, same is a different from your resistance. Okay, when it's connected in parallel, you must calculate as a in series which the resistance. Dia macam bila awak connect dalam bentuk secara parallel, kita kena gunakan kaedah secara sesiri seperti resistance. Contoh sekarang you ada C1, C2, C3, Cn, etc. Okay, and connection of the capacitor. Okay, so you kena kira C equivalent dia sama dengan C1 plus C2 plus C3 and until Cn. Okay, example, I give you the example here. Okay, determine the equivalent capacitance between terminal A, B. Okay, so you have 20 microfarad here, 5 microfarad, 6 microfarad, 20 microfarad. Okay, for 20 microfarad and 5 microfarad is in series. So you must use the calculation 1 over. Okay, then it parallel to 6 microfarad in parallel plus. Okay, because you act as a you do it by as a series resistance in parallel. Also plus 20 microfarad. The last one will be in series 60 microfarad. So you must solve it by using 1 over. Okay, so the solution I give you here. Okay, I give the explanation also. The microfarad and microfarad capacitor are in series, so the equivalent capacitance is, you must do it by using like a parallel concept of resistance. Then the 4 microfarad in series with 6 microfarad, so you must add up it until 20 microfarad is also in parallel. So you add up it like as in series. Okay, even though in capacitor it must be in parallel lah. Okay, the last one, C equivalent in series, you must do the calculation based on parallel concept. So the answer here, okay, C equivalent. Okay, you can try the exercise 1 here. Okay, the answer is given to you. Okay, exercise number 2. Okay, for this one you can ignore it. Okay, no need to example 2, you no need to do the calculation V1 V2, no need. Okay, we just focus on series and parallel concept only, the total capacitance and the total inductance only. Okay, for this chapter. Okay, you can ignore this one. Okay, for inductor, same. Okay, inductance, we use same as a storage element. Okay, so passive element able to store energy in its magnetic field. Okay, inductance, the property whereby inductance exhibit the opposition to the charge of current flowing through it, measured in Henry. Okay, capacitor we measure in a farad. Okay, inductance we measure in Henry. The value of the unit is Henry. Okay, and inductor acts like a short circuit when connected in DC in a long time. Okay, the current through inductor cannot change instantaneously, same as capacitance. Okay, capacitance we focus to the voltage. Okay, the difference between the plate, the voltage, but in inductance we focus on current flowing. Okay, so you must know, okay, for the capacitance we usually focus on the different voltage between the plates, that's mean in V, but in the inductance we focus on the current flowing, okay, through the element, through the magnetic field. Okay, so it will produce the current. So inductance we produce on current. Okay, so the current same as capacitance, it cannot instantly reduce quickly or shortly change the value, but it will reduce dia secara perlahan-perlahan dia akan reduce the value, not just instantly to 0, for example. Okay, so same as inductance, the current through inductance cannot change instantaneously. Okay, the most important part, you must know the equation is this one. Okay, the second equation is this one, same as capacitance. So the capacitance, we must know the equation, inductance, we must do the equation for V, for same as the work done here. Okay. Okay, for series inductance, we apply as the same as resistance. How to calculate the resistance? Same as inductance. For example, here, for this one, L1, L2, L3 until Ln is all in series. So add up as usual. You tambah macam biasa. So L equivalent equals to L1 plus L2 plus L3 plus Ln. So remember, for series connection, the single node only shared together. Okay, only single single node, single node, single node sharing together. For parallel inductance, yes, exactly same as a resistance. How you apply for resistance, same. You apply here, okay. When L1, L2, L3 until Ln is in parallel, you do 1 over L equivalent, 1 over L1 plus 1 over L2 plus 1 over L3 until 1 over Ln. Okay, same as you apply to the resistance. Okay, here I give you one example. Okay, more than one example. Okay, for example here, 20 Henry to 12 Henry and 10 Henry is all in series. So you add up as usual, 20 plus 12 plus 10, and in parallel with 7 Henry. Yes, you must do the calculation 1 over the last one. Add up as usual, because 4 Henry, 8 Henry, the equivalent inductance you get here all now in series, so you add up as usual. Okay, so here the step how to define the parallel inductance. Okay, step by step. Okay, here, and here. Okay, so the just a little bit different. Inductance is very clear, same as you do for resistance. Okay, this one example exercise. Okay, I give you. Okay, exercise 5. I want you to do as a exercise and you must submit. Okay, so this one as your exercise, you must submit in Kalam by next week. Okay, thank you.